Hello, Year 11. I hope you have had a lovely break over the holidays and has relaxed if you've got away somewhere. I hope it was a lovely trip. We're back on very shortly. So, in response to a few emails that I've received, there are some of you that are a little confused with the experiment. So, I wanted to go through this and I've done it as a YouTube video, which means you can rewatch and look through what I go through to help you write up this prac. All right, having a look at this, you've got some information at the top here which says a standard solution is a solution with a known concentration, and a series of these can be used to produce a standard curve. An aliquot is the volume dispensed from the pipette, so that's what we use to transfer that volume backwards and forwards to each of those, well, not backwards, but forwards to each of those standard flasks that we made up. Now, the whole idea with this experiment is to produce our standard curve. And what are we trying to figure out? We have an unknown solution there that we don't know the concentration of. So in order to do this, we are producing our standard curve. So this will lead you a little bit into what the hypothesis is, I'm hoping. Let's read on. Prepare a coloured solution and then use pipettes and volumetric flasks to prepare a series of diluted solutions. You'll then use the colorimeter to measure these solutions to determine what an unknown solution's concentration should be or could be. So this is what leads us into our hypothesis. Remember, our hypothesis is a statement which says if we do this, then we can measure this. That leads us into our dependent and independent variables, and this often gets us very confused. That independent variable is the one thing you are changing. So in this experiment, what is the one thing we are changing? It is our concentration. The dependent variable is what you're measuring. So we're using our colorimeter to measure something. I'm leaving it there because I don't want to give away too much, but I'm hoping that that will help you understand what your independent variable is, so the one thing you're changing, and what the dependent variable is, so the thing that you're measuring for this experiment. Your aim obviously is to find the concentration of that unknown solution. So we have our materials here. We have our copper sulfate that we're using, that's our solid that we made up first. Then we transferred that into various different volumetric flasks, looking at the concentration. Remember, we had to measure that to the bottom of the meniscus when we did this. So there is an example of some sort of error that you could talk about. Coming down to our procedure, you've got your weighing. You had to make sure that that was pretty accurate when you weighed it. You placed it into the funnel, you rinsed it with distilled water, and you made sure that all of that solid went into the standard flask. You then filled that up, swirled it around, made sure you dissolved everything, and then once you were dissolved, you filled it right up to the bottom of that meniscus line. That calibration line, as you recall, was different for each one of those flasks because they're measured specifically to hold exactly the amount that they say they are. So if it's 100 ml volumetric flask, then it will hold 100 mils exactly if you fill it to the bottom of the meniscus. You then had to remove 50 mils from the first volumetric flask into a second volumetric flask and top that up. So you've diluted that. And if we've got a 100 mil standard flask and you've taken out half of it, I'm hoping you can figure out your dilutions. Then we repeated those steps, ensuring each aliquot was taken from the most recently made flask and continued that dilution by half all the way down. You were taking photos of those flasks as you went, and you needed to record in an appropriate table the colour of each solution. So you need to be a bit descriptive here. You're talking, we're getting into chemistry, we're getting into what are you actually seeing. You want to be as descriptive as you can for each of those colours that you saw. Your colorimeter readings, you then took your readings and went to the colorimeter, inserted it to gain the reading. You had to have the colour set on red. Each one of those readings spat out from the colorimeter is exactly what you're plotting. Each one of those readings that you got from the colorimeter is the actual reading that you want to graph on your graph. You repeat steps 16 and 17 for each of your volumetric flasks, which means you should have colorimeter reading for each of those. You then grabbed the unknown and you measured the unknown. So after you had all of your standard ones measured and you got the colorimeter reading for each one of those standard ones, you then measured your unknown. Your unknown is not the one you graph, that's the one you're going to use your graph to read the concentration on. So when you're going and graphing your results, you just want to graph your standard solutions on a graph. Keep in mind where your IV and your DV goes on your graph. So your independent variable and your dependent variable, if you don't know where they go, look it up. Google is our savior. Ta-da! Please have a look where your independent and dependent variables go on your graph. So you've got a table which you've written down all those concentrations, you've written down your unknown in there, and you're using that standard curve. So this is this one here. You're using your standard curve to determine the concentration of what the unknown could be. So don't graph your unknown as a solid point where you draw a line of best fit. That's the one that you're using the line of best fit to look for your concentration. All right, so keep that in mind. You're not adding that to your values before you draw your standard line. Okay, remember your standard curve should be a line. It's deceptive in the way that it says standard curve. It's not a curve, it's a line, and you need to draw a line of best fit. So if your dots don't exactly line up, don't draw them so you're kind of doing a dot to dot. That's not what you want. You want a line of best fit through all of that. So grab a ruler, stick it on there, maneuver the ruler so you get your line of best fit. Then you come along with your unknown, you rule up, hit the line of best fit, and come across and figure out the concentration, the possible concentration of your unknown. So your results, you should have a table or two tables, depending on how you do this. You could incorporate it into one table. You should have on there your photos. You have in your table the colors of each solution, and then perhaps if you do it in one table, the next column would have the colorimeter readings for each of those solutions. You also need the concentration, so you need to work out the concentration of each of those. You then need to complete your evaluation. So classify your results and calculations as qualitative or quantitative. Now, your textbook has a whole section on this. I think it's either chapter 1 or chapter 12, I can't remember off the top of my head, but your textbook has a whole section on doing experiments, and we will look at this when we start to do our poster. This will help you in writing up your prac if you can't remember how to do these sorts of things. Your qualitative and quantitative data is in there. Your independent and dependent variables are in there. How to graph is in there. So all of those details are in your textbook. So if you already have your physical copy, then you can start looking through that. If you had the opportunity to repeat the experiment, what would you do differently? And evaluate what went well and what did not in your experiment. This is where you can throw in your errors through your evaluation. What sorts of errors did you see? What could you repeat? What could you fix up with this experiment? Your conclusion, don't forget, when you do your conclusion, you need to restate your aim as an affirmative statement. You need to refer to your hypothesis. Was it supported or refuted? Any further research that you could do here could go there. So any ideas about what you could use this for or how you could implement this procedure. We use this a lot in the labs. This is a common thing that we do to identify an unknown solution. There are references and any sources that you might have used you can pop in here as well. So your textbook could be one of those places where you've looked up your IV, your DV, all of those sorts of things. If you've grabbed something off the internet, write down what the site was that you used. There is also a really great video there that I've linked about how to do your standard curve. So if you're still stuck on that graph, I really encourage you to have a look at that link down the bottom there to analyze and go through how to draw up your standard curve. Because a penguin professional, she's fantastic, goes through what to do with your standard curve. If you have any further questions, please don't hesitate to yell out. Send me an email, but obviously I will be sporadic in returning those emails. So if you do have any other questions, please do. Hopefully this is helpful. Let me know if it is. If there's any further stuff that you need, again, let me know.